All right, in this lesson, we are going to go over how to multiply polynomials. And we've got maybe a couple of lessons to do like this. Today we'll cover multiplying monomials with a polynomial. Um, but the method I show, you'll be able to use it in any situation. And also, I will play some music in the background. If it's distracting while watching the video, let me know and I won't do it again. But I figured it would be nice to have that in the quiet moments of the video. All right, so let's get to it. I'm going to share my screen with you all so you all can go through the notes. And I'll keep the music playing in the background because I like it. All right, here we have it. So this is lesson 2. This will be in the lesson 3 folder, I believe, but this is the second set of notes we have. So lesson 2, second thing we're learning for this unit. And as usual, we start with our essential question, which is going to be, how can I multiply a monomial by a polynomial? All right, and for the lesson today, I'm sure the fact that we've gone over the vocab beforehand, it's going to be really useful. We have monomial, which is one term, binomial, which is two terms, so something plus something or something minus something. Then we have a trinomial, something plus something, or something minus something, or any combination of pluses and minuses that you can put in it. Usually for trinomials, we just call them polynomials. Polynomials will work for anything that's more than just one term. Anything that's one term will just be a monomial. All right, so let's keep on going with this. As we go through, it's really important. I'm going to put this one in red. It's really important that we recall the distributive property. The distributive property is what we use when we have one monomial or one polynomial minus another. We distribute that minus sign to every term in that second polynomial. We're going to use that same type of thing when we're multiplying these polynomials. Okay, so it says, recall, the distributive property is used to multiply a single term and two or more terms inside a set of parentheses. So for example, and no doubt you've seen something like this before, 3 times 2x plus 5, this 3 gets multiplied to this 2x, and it gets multiplied to that 5, all right? So as a result, we end up with 3 times 2x. When we multiply these things, we get a 6x, and then 3 times 5 is 15, right? We have just distributed this 3 to the 2x plus 5. And this isn't something, this is something you've seen before. It's not anything new. Like I said, we've done it with the multiplying or with the subtracting polynomials, and we'll do it with these multiplying polynomials, okay? When we have more constants, have more than a constant to distribute, we can use what is called the box method. All right, so let's put this right here, and this one I'll put in blue. I won't need it in red. The box method. All right, this is one method of many for, not the bow method, box. It can help us track our multiplication a little bit easier. I'll show you both ways. I'll show you the box method, and I'll show you just how to do it with distribution. Some students will have a preference, which is why I'm showing you these different things, okay? So this first example says, use the box method to simplify the following. 3x times the quantity 2x plus 5, all right? So I'm going to draw a little box. I'm going to use this little tool. It'll do a box for me really nice and pretty. If you're using Canva, you can do it this way as well, or you can just draw one by hand. So we have 3x times, you know what? Let me scoot this box over. There we go. We've got 3x times 2x plus 5. What we do, this will be, we'll have 3x on, we'll have 3x on the side, and then 2x right here, and plus 5 here. All right, so we got a box, and then we've got these two sides for each of our terms. This first box will be 3x times 2x, right? So 2 times 3 is 6, and then x times x is x squared, okay? X times x is x squared. Think back to your law of polynomials. Anytime you had x times x, that was equal to x squared. Same thing here. Now, when we do the second piece, this 3x gets mixed with this 5. So 3x times 5, since these things are being multiplied, 3 times 5 is 15, and that x still just tags along. And here we have it. That's box method. That's pretty simple, pretty easy to see, right? And then our final answer is going to be, what color can I use for that? I use yellow. It's going to be 6. Oh, you guys said yellow was hard to see. I'll keep it in pink. Actually, I'll put it in black. All right. Final answer is 6x squared plus 15x. All right. That's going to be the final answer we get when we multiply these two things together. When we look at another example for this box method, we have a monomial with this, which is this 2p times this p squared minus 6p plus 1. We can use the box method for this as well. And honestly, you can use the box method for any setup, any situation. So let's look at this one. We start off with our box. This one's going to be a little bit longer because we have more terms. We've got 3 terms in here. A line there, a line there. Like usual, we start off with our monomial on the side, 2p. And then we have our trinomial. That's our little vocab words there for you on the top, separated. P squared in this first one, then negative 6p. Remember, we keep those signs with them, especially if they're minus signs. Those minus signs need to tag along. Negative 6p, and then a 1 plus 1. So on the top, we've got it, p squared minus 6p plus 1. And then we just go through and multiply this 2p to each of these terms and put it in the box below. So 2p times p squared, we get 2p cubed, because p times p squared, p times p squared, p times p is going to be p times p, which is p cubed, okay? And this is why we took the time to learn and master our laws of exponents, because they come back right here and now, right? But all of you all did well with that unit. So we'll keep on going. So this is 2p cubed. 2p times negative 6p is going to be negative 12p squared, because we get this p times this p. And then finally, 2p times 1. It's just going to be 2p. We know how to do that. And then our final answer is going to be 2p cubed minus 12p squared plus 2p. All right, you see how I did that? I really just took these numbers, this number, that number, and that number, and wrote it down. I don't have a sign written right here. If our number is positive, we could just write plus. If our number is negative, that should be written out, and we bring that minus sign down with it, all right? All right, now I want you all to try number 3 on your own with this box method. After you try number 3, let's move on to number 4. This says, simplify each expression by distributing, then combining like terms. And this is another method that I was telling you about earlier with distribution. We've done it before, and we can use it in almost every situation. We don't have to use the box method. So if you like that, use that. Here's another possible method you can use. And it works for, right now we just have a monomial on the outside. It would work for monomial, binomial, trinomial, any kind of nomial, any polynomial. This 3 needs to go to this 5x squared, to this 2x, and to this negative 4, okay? We need to do that first. Once we finish that, we need to come over to this side. And instead of just distributing the x, I'm going to distribute this negative x, okay? 2 birds, 1 stone, 1 move. Instead of doing x and then doing the negative, we'll do negative x. That'll make it quicker. So that negative x to the 7x squared, to the 2x, and to this negative 3. All right, so now let's begin. I'll keep 1 in pink and one in purple. So 3 times 5x squared, we really just multiply those numbers together. That 3 times that 5x squared gives us a 15x squared plus 3 times 2x is a 6x. 3 times 2 is 6. That x still tags along. And then finally, we have this 3 times this negative 4, which is going to be a negative 12. All right, so that's this first one taken care of. And now we're going to look at this final one. I'm going to put these in parentheses because these things will have a plus in between them. And here's a great way. Once I finish this is a great way to hammer home the difference between multiplying and adding and subtracting. All right, let's deal with this x. Negative x times 7x squared is going to be a negative because that's a negative 7. And then we have x cubed. Ooh, that's a 2. This needs to be a 3. X cubed. We get that because we have an x times the x squared. My x squared. When we put them all together, we get 3 x's, x cubed. All right, then we'll look at the next one. We have a negative x times a 2x. That's going to be a negative 2x squared. And then finally, we have this negative x times this negative 3. Negative times a negative is a positive. And then x times 3 is going to be 3x. All right, and so there we have it. We distribute it. It's pretty quick, pretty easy, very much painless. And now our final step is going to be to actually line up our like terms, underline our like terms, line those things up, and then combine. So I have an x squared there, an x squared here. I have a 6x here, a 3x there. I have a constant here and nothing else with a constant. And then finally, I'm running out of colors. I have a negative 7x. All right, that's all I have for my identifying my like terms. Sometimes I actually write those out. I'm going to write them out over here instead of underneath like normal. I have a 15x squared plus 6x minus 12. And then I have a negative 7x cubed. I wrote that out to the side because I don't have anything cubed to match up with it. Minus a 2x squared plus a 3x. And that's what I got. So now I'm actually just going to go through. And since we went ahead and already distributed that negative with that x, we change that to a positive and we just add these things up. This 7x comes right on down. So we got negative 7x cubed. Then we've got 15x squared plus a negative 2x. That gives me a positive 13x squared. And then we've got a 6x plus a 3x is a 9x minus 12. This 12 didn't have a partner with it to combine. And so we bring it right down. And here's a big difference between adding and subtracting, or not adding and subtracting, between adding and multiplying. Adding and subtracting and multiplying. When we multiply, we aren't concerned with like terms. We just smush them all together, we multiply them, and what we get as a result. We can multiply things that aren't like terms. We can multiply this 3 with this 5x squared. These things aren't like terms. We can't add or subtract them, but we can multiply them. We don't need like terms to multiply, but we do need like terms to add or subtract, okay? And that's the big difference. So I want you all to try out number 5. And lastly, I'm going to do one of these examples, and I want you all to try the other ones because they are pretty interesting. And I think you'll do pretty good at these. This is like the IXL that we assigned for the last class. So this question says, what is the area of a rectangle that has a length of 4x and a width that is 3 more than 4 times the length? 3 more than 4 times the length. That sounds confusing, right? Okay, so let's set it up. With this application problem, we're dealing with a rectangle. So I'm going to draw a rectangle. Pow. On Cami, it's super easy to draw shapes. So that's what I'm going to do. And we're looking for the area. Here's something that a lot of students kind of get confused, just thinking back to what those geometry things are. The area of something, of a rectangle, area of a rectangle that has a formula. Area equals length times width. All right, we'll need that and we'll come back to that later. But let's get started. It has a length. It's 4x long. So boop, boop, 4x. And then it says it's 3 more. So that's something plus 3. So 3 more than. This is where we got to use our translating skills. 3 more than 4 times the length. So if the length is 4x, 4 times 4x, it's going to give me 16x. All right, we just got to do a little bit of math to get here. And boom, there we got it. There we go. We got it set up. And to find the area, we just multiply these things. So we've got A is equal to L times W. A is equal to my L is 4x and my W is 16x plus 3. So A is equal to 4x times 16x plus 3. All right, so this question started off looking really tough and intimidating, but it's super, super duper simple. So let's go ahead and finish it up. With this 4x times 16x plus 3, we distribute the 4x to the 16x and to that 3. And when we do that, 4x times 16, 4 times 16, you can go ahead and plug that into your Desmos. I believe that's 64. If I'm wrong, somebody let me know. Or just ignore it and type it in the calculator and use that answer. 64x squared, don't forget because we have x times x, it's going to be x squared. And then finally, 4 times 3 plus 4 times 3, and that is going to be 12x. All right, there we go. That's how we do this. This wasn't hard at all. The setup was interesting. It took a little bit more work to get there, but it was very doable. All right. The rest of these, number 7 is very similar. And then number 8, you might have to take a little bit of thinking skills together, but I'm pretty sure everybody can do it. So go ahead, work on this. And when you finish, you can come back to the Zoom chat and we'll ask any questions you have first off, if you run into any, and then we'll have some classwork in an Excel to do, okay? So work on that. And like I said, always, if you have questions, let me know. At the bottom, there is a summary. I didn't scroll to it because I forgot, but go ahead, do that muddiest point. What part did you get confused at? And what helped you get unconfused? Do that, come back to Zoom, work on the classwork and the iExcels, all right?